right, so we're going to start off right here. This is 5.1, part 2. Okay, we're still talking about quadratic functions, but today we're going to talk more specifically about vertex form. This is kind of the point of interest today. Vertex form of a quadratic function. And so on Thursday and Friday of last week, we looked at quadratic equations. We looked at quadratic functions in the form of y equals ax squared plus bx plus c. This is called standard form. Standard form. And from that, we could get some good information. You did that whenever you were graphing your equations. You got the axis of symmetry, negative b over 2a. You used that information to find the vertex. You can tell from A whether it's a stretch or a shrink, whether it's reflected. What does your C tell you generally? Your y-intercept. Okay, so we've got lots of information from this particular form. However, there is another one called vertex form, and it says f of x, and I probably should have used f of x up here as well, because we're used to function notation. So f of x equals a times x minus h squared plus k. Y equals a times x minus h squared plus k. And this particular form is called vertex form. Huh? Plus k minus h. X minus h squared plus k. What is so cool about vertex form is that you can eyeball the function and tell where the vertex is. It tells you exactly where the vertex is located. The vertex is going to be located at h comma k. H comma k. And if you go back to your transformation laws, you can see it. Where is h? Where's h located? Look at this function. Where's h located? In the brackets with x. Can you tell? He's right. That's exactly what I'm looking for. H is located in the brackets with x, inside the parentheses. Can you see it? It's right here, in with x. What does that make h? It's an insider. It's an insider. It's a liar. So, if this had said x minus h, and let's let h be 2, x minus 2, which way did this parabola go? Right 2. See why your vertex is located at h comma k? This will tell you where it moved to. Okay. K is an outsider because it's located outside of the y-axis, outside of the x stuff, right? So this is going to be an outsider. And what does it tell you? The truth. And it tells you up, down. She's right. It tells you up, down. Okay? So your vertex is going to be located at that h value and the k value. Pretty neat, huh? So you know already all about this. You already know how these transformations are going to work. If h is positive, I'm going to the left. If h is negative or it shows x minus h, we're going to the right. Okay? And then k is an up-down kind of thing. So you can already envision how this is about to play out with our parabolas because you've already graphed absolute value functions in this form. Okay? You know those memes that say, like, I was today years old when I figured out, blah, blah, blah. You know what I'm talking about? The today years old things? Well, I was like yesterday years old when I figured out that this a value is this a value. They're the same number. Okay? This was maybe 5 years ago that I realized that. I was well out of college and had already been teaching for a minute when I put together that, hey, that a is the same number a here. Okay, so the role that this a value plays up here where it tells you whether it reflects or whether it's fat or skinny, they're the same number and they do the same exact thing. Okay, so that's one of the coolest. This is still stretch factor. This is still your stretch factor. It still tells you whether or not it's reflected. Okay, your H value is still responsible for horizontal shift. And your Y value or your K value out here is still responsible for vertical shift. So algebra is kind of nice sometimes in that some things never change. These transformation laws will always hold. All right, so let's see what we can get into here. This is example 3. Example 3, and it says, write an equation for the quadratic function OMG. Now, write an equation for the quadratic function as a transformation of f of x equals x squared. So here is your f of x equals x squared. It goes through 0, 0, 1, 1, 2, 4. Do y'all recognize this toolkit function?
Yeah.
Excellent. Good, Marcus. I like it when Marcus is awake.
I'm trying to say where I focus more on the lesson than I do on taking my notes. So I'm going to put my whole 100% towards the lesson.
Marcus is putting his whole 100% toward this lesson. I like it. Okay, so this is the new function. Its vertex is actually located over here. This is, and it goes through 0, -1, and it goes through 1, 0. Okay, so some points that I'm kind of mapping out here. New parabola. Okay, and in the textbook, you could actually see where these points are. I'm going to have to help you guys out a little bit to see on my grid where they are. So this is located at -2, -3. This is the vertex. Okay. And then another point that came out super ugly on my picture up here is this one right here. And I would say this is 0, -1. That's an x and y value. Y'all seeing what I'm seeing? Okay. So all we need in order to write an equation, we need a vertex and we need another point. That's all. Okay? Because if we use vertex form, it says this: f of x equals a times x minus h squared plus k. And my vertex is located at the point h, k. And this point over here that I gave you, this little bonus guy, is located at x, y. So out of all of this information, we have a y value, we have an x value, an h, and a k. What do we not have? An a. So we can solve for it. Okay? So this is just like in the linear stuff when they give me m and they give me a point and I got to solve for b. Same exact idea. Okay? So on this equation, I'm going to replace f of x with y. What's y in this particular problem? -1. And you could have used any point here. I noted the point 0, -1 because on my graph it's the easiest one to see. Okay, so we're going to replace y with -1. We're going to call a. But this x value is going to be what? 0. X minus, what's h? Okay, it's minus -2. So this is going to come out as 0 plus 2. Can you see that? Squared plus, what's k? Okay, so instead of plus -3, let's call it -3. So we're just plugging in all of these little numbers into that formula. Everybody okay with that? 4. So he's got 0 plus 2 is 2. Squared is 4. So let's call that 4a minus 3. Add the 3 to the other side. So 2 is equal to 4a. A equals not 2. 1/2. And can you tell that by this fraction? Can you tell it's got a vertical stretch of half? How can you tell, Marcus? What is it? Insult it. Tell it all day long what it is. It's fat. It's fat. Katie's got no problem. It's fat. Can you tell? Can you tell it's fatter than the parent function? It's because it's compressed by a factor of half. Okay? So we've got half, open parentheses, x minus, or x plus 2, sorry. So it shifted to the left 2. So it's an insider that lies, so it goes in as plus 2, right? Can y'all see that? H was actually at negative 2. But by the time it hit our function, it goes in as plus 2 because insiders lie. X plus 2 squared minus 3 because it did in fact shift down 3. That's how you do that. Write an equation for the quadratic function as a transformation. So you're going to pull the vertex and you're going to use a point. This happens repeatedly in your homework. Pull the function, the vertex, use a point, solve for A. Questions on this?
I feel like the x squared, that x squared equation is easiest.
Okay, and so he says he feels like f of x equals ax squared plus bx plus c. You can get there from vertex form. So if we just had this function f of x equals half times x plus 2 squared minus 3. How can I put it into f of x equals ax squared plus bx plus c? Or were you saying you felt like the toolkit function itself was the easiest one? Yeah, I would agree with you. I like it. Quadratics don't bother me. But you can go from one form to another. How might we do that here? You already have a, half is half. But how do I get that x plus 2 squared business expanded? Am I allowed to go in here with this 2 and go and call it x squared plus 4? No. No. My algebra teacher said no. No?
You
Factor. Foil it. Yeah, expand it out. So we want to say instead f of x equals half times x plus 2 times itself minus 3. Right? We're going to FOIL. So we keep going. Half x times x is x squared. That's first. And then outside we have a 2x. And inside we also have a 2x. What's 2x and 2x?
4x.
Plus 4x plus 2 times 2, 4. So that was first, inside, outside, last. Y'all remember doing this before? And then our minus 3 on the end. So then we're going to have to distribute this half throughout here.
That's just way too much work.
Oh, it's not too much work. You're a big kid. You got this. Half x squared. What's half of 4? 2x. What's half of 4 again? Minus 3 on the end. So I can combine these two. They're like terms. So we've got half x squared plus 2x minus 1. Same exact function in a different form. Same exact function. It would have graphed the exact same picture. Okay. Now this is a beautiful segue into the next example. You got to trust me on that. I know you don't think it's a beautiful segue. I'm telling you, this is a beautiful segue into the next example. Here comes example 4. Example 4 says convert from standard form to vertex form. Convert from standard to vertex. Okay, and you've already done this. You've already had to find the vertex given standard form equation. You've already done this. Okay? So let's see. Given f of x is equal to 2x squared minus 6x plus 7. We want to write this in vertex form, which says f of x equals a times x minus h squared plus k. Can we use this standard form equation, 2x squared minus 6x plus 7? Can we use that form to locate the vertex? Yes, she's saying yes. How? Negative b over 2a. That's our starting point. What does that little equation give me? When I do x equals negative b over 2a, what am I finding? The axis of symmetry. This gives me the axis of symmetry. Well, where is the vertex located? It is on the axis of symmetry. So I can find that x value, and in fact, this could be called h, because it's the x point from my vertex. This is h. Okay, so let's find it. Let's find it. Negative b over 2a. What's b here? 6. Negative 6. So negative 6 over 2 times what's a? 2. 6 over 4 or 3/2. Well, there's my h value. So in here I'm going to have x minus 3/2 already. I know that piece. How do I find k? Your k value is going to be equal to f of that h value. It's the y value. It's the output. So if you find 3/2 as x, that's your input, put it into your function, f of 3/2 is the y value for the vertex, the output. So we're plugging back into this function 3/2. So we got 2 times 3/2 squared minus 6 times 3/2 plus 7. It's 3/2 squared. Three halves squared, that's 3 squared over 2 squared. 9/4. 9/4. So we've got 2 times 9/4 minus, I always cancel my fractions. I don't know. I teach at this school, and I don't think y'all were here the day that they taught you how to handle this. 2/4. How many times can 2 go into 4? 2. So I'm going to cancel the 2, and I'm going to write a 2 under where the 4 was. Well, you could call it 19 or 18/4, or you could call it 9/2, right? Minus, I'm going to cancel this 6 with this 2. How many times can 2 go into 6? 3. 3 times 3 is plus 7. So I have 9/2 minus 2. What do I want to call that 2 so I can subtract 9/2? 4/2? Uh-huh. So I could call it negative 9/2 minus 4/2. Puts me at should have landed at 5. What happened here?
Miss, how'd you get a negative on the 9? Oh, real.
I should have gotten a negative on the 9. I don't like my first one. It should have been It is 3/4. It's 9/4. I think that my key on my work over here doesn't match. I don't think we have a mistake. Do y'all find a mistake?
I don't know where you got negative 9 too.
Okay. Give me a second. I don't think we have a mistake.
Where did the negative 9 over 2 come from? Yeah, I just don't understand what I mean.
The negative 9 over 2?
Yeah, it was positive.
Oh, yeah. Y'all are right. Good catch. This right here. That's a 9 halves minus 2. Positive 9 halves minus 4 halves. Now we're cooking. Good job. Way to catch that. Somebody said that a long time ago, and I didn't understand what you were saying. So K is 5 halves. Now we're good. Now we're good. Good catch.
The 2's don't cancel?
No. They combine. We're subtracting them. 9 halves minus 4 halves is 5 halves.
The 2's at the bottom. Why don't they go away?
Because we're combining fractions. If I have a half a pi plus a half a pi, I got a whole pi. We're good here. We get K. Right here, 6 times 3 halves. That's 18 halves, which is 9. Okay, so we just put H and K into this equation. What's A? 2. I'm telling y'all, this was a revelation for me. When I realized that number 2 right here, this is the same A value here. Okay, so if we're going to finish writing this function, we've got f of x equals 2 times x minus 3 halves squared plus 5 halves. Okay, so this is how you can convert from standard form to vertex form. You find the axis of symmetry and plug that in to get the k value, and then you rewrite it in vertex form. Okay, this is really heavy on your homework as well. Do we want one more of these? You mean to give you one of your homework problems? Okay. We do. We have time. Yeah.
I got a question. So next year, what would you get your advanced quantum reasoning or advanced math?
Color prep now.
Yeah, because my grandma said, no, this one's easier. I was like, no. I'm gonna freaking feel it.
All right, let f of x equal... I'm trying to pick the hardest one of your homework questions. Let f of x equal 2x squared minus 6x. And we want to convert this to vertex form. So all we have to do here is find the vertex.
Where's the C?
There's no C. This is on your homework. This is number 12.
Makes it sound so easy.
Yeah. There's no C. So it's fine. Vertex form doesn't involve a C, remember? It's f of x equals a times x minus h squared plus k. There's no C there. How do I start? How do I find the vertex? The h value. Negative b over 2a, right? So h, or x, is equal to negative b over 2a. Well, what's b here? Negative 6. So we're going to have negative 6 over 2 times 2. This is the first time that we've had negative, right? If my b term is negative and it goes into that equation, it comes out to be positive.
We just did this. It was...
Awesome. Go us.
Okay, but...
It's not the same problem.
Kind of is.
What'd we get? 3 halves? Right? 6/4? Well, y'all hated this while ago, so I figured we'd do it on your homework and see if it got better. Okay, so h is 3 halves. So how do I find k? Plug it in. So I need f of 3 halves, which means I take my function 2 times 3 halves squared minus 6 times 3 halves. Plug it in. What's 3 halves squared? 9/4. So 2 times 9/4 minus, you could go 6 times 3 is 18. 18 divided by 2, 9. What's 2 times 9? 18 divided by 4. 18/4, also known as 18 and 4. They're both divisible by 2. 9/2, okay. So 9/2 minus 9. And I would need to convert the 9 to be in halves so I can subtract those. 9/2 minus, what do I want to call 9 in terms of halves? Okay, call it 18 over 2. So 9 minus 18 over 2, negative 9/2, right? Negative 9/2, this is K. So now I need to fill in my numbers. I got to write it in vertex form. F of x equals, what's A? 2. This 2 right here. 2 times x minus, what's h? 3/2. That's this number right here. X minus 3/2 squared minus 9/2. That's your K value. Think we can live with that? Okay. We'll try to do part 2 tomorrow.
Guess we'll find out.